So let me give you guys another example. So in this video, we're going to try and integrate the inverse tan of x. And before we do this, I would need you to be able to differentiate this thing here. So when you differentiate the inverse tan of x, it will give you this thing here. Okay, so I would also ask you to be able to do this by heart. So train yourself to be able to show that when you differentiate this, it will give you this. Okay, so in this video we are going to try and integrate this, but before we can tackle this problem here, let me just quickly zoom through that when you differentiate this, it will give you this. So we've already seen this in the past many times. I'm asking you to train yourself to be able to differentiate this, well, get from here to here, and be able to do it by heart. So the first part of this video is me showing you how to get from here to here, and then after that we will tackle this. So we've seen this many times. I'm just going to whiz through this. If you don't understand it, then track back one of the earlier videos on how to differentiate the inverse tan of x. Okay, so to differentiate, to show you this, start out with tan of x equals this thing here, and then if tan of x equals this thing here, then use the reimagine it as this, and then use the product rule. So when you differentiate it, it will give you this thing here. So I'm just whizzing through this. If you don't understand it, then track back one of the earlier videos. So once we know that if you differentiate tan of x, it will give you this thing here. Now look at this inverse tan of x now. So inverse tan of x, we're going to use implicit differentiation. So first thing, from here we would tan equally to both sides. That would then give us this. Differentiate y, so that will then give you this. Because y is a function of x, we've got to use a chain rule, so times it by dy by dx. Differentiate this, it will give you 1. So now you want dy by dx on its own, so you times cos squared of y. That will then give you this. So now our answer, dy by dx, equals this. But the thing is, we want the answer in terms of x. So so from here we would travel back to here, and then look at this statement, and then create a diagram where this statement is true. Well, the diagram that you see here, if you look at this here, tan of y, so tan would be this. Let's say the angle here is y. Create a scenario in such a way that this statement is true. So let's say this length here is x, and this length here is y. So tan of y, which is this bit here, this is tan. Tan of y equals x over 1, which is true. So looking at this diagram, it will give you this. Well, if this here is x, this here is 1, then the hypotenuse here must be this thing here. So so remember, we were here, and then we wanted to translate this cos of y. At the moment we've got tan of y. We're going to try and translate cos squared of y. So cos would be this thing here. So that would be 1 over root square blah 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 blah. So y, cos of y equals this thing here. So therefore cos squared of y equals this thing here. Overall dy by dx equals this thing here. Okay, so now we know how to differentiate in inverse tan of x. So now let's try and integrate now. So remember, you should be able to do this by heart. Okay, so train yourself to be able to get from, train yourself to be able to do this by heart. So from here all the way down to here, you should be able to do it by heart. Train yourself to do it by heart. Okay, to get to here. So dy by dx equals this thing here. So now let's try and integrate this now. So I will continue in the next video. Okay.